So here we're doing some problems in chapter 1.4 in class. Please review these problems. So our first objective is using the square root principle. So we're looking at problem number 33 on page 145, and it's solved by applying the square root principle. So in this problem we have t minus 1/2 square of that is equal to a negative 17 over 4. So our idea is we take the square root of both sides of the equation. When we do that, we get t minus 1/2 is equal to plus or minus the square root of a negative 17 over 4. Now, t minus 1/2 is equal to plus or minus the square root of a negative 17 divided by the square root of a negative of 4. So now t minus 1/2 is equal to plus or minus the square root of a negative 17 over 2. And t minus 1/2 is equal to plus or minus the square root of 17i, because we have the negative square root taken out, and that's by definition I, over 2. So t is equal to 1/2 plus or minus the square root of 17i over 2. Now we have a common denominator 2, so t is equal to 1 plus or minus the square root of 17i divided by 2. So there's our answer. So our second objective is solving a quadratic using factoring, but the first step is to get it into quadratic form. That means using the zero principle. So we're going to distribute the 6. We get 6m squared plus 24m is equal to m minus 15. We subtract m from both sides, so we get 6m squared minus 20 or plus 23m is equal to a minus 15. And to get it in quadratic form and using the zero principle, we'll set this equal to 0, so we get 6m squared plus 23m plus 15 is equal to 0. Now we can set up the factors for this particular problem. It turns out that we would be looking at the factors of 6 and the factors of 15 to find how to break this up into two separate factors. Notice the two factors that we can break it up to is related to the square of the first term of the polynomial, the highest degree of the polynomial. So that's how many factors that, if this thing is factorable, it could be factored into. And so it turns out that in this particular case we have a 6m, and then we have 5 and let's see, 5 and 3, is it? Let's see, 6 added to, yeah, so it's 5 and 3. So it's 5 here and 3 here, and so they're both pluses, right? And you want to check to see if, in fact, your factors work out. So when we FOIL this, when we FOIL back into this, we get 6m squared plus 18m plus 5m plus 15 is equal to 0. And this gets to be 23m, so we're okay. So now we have two factors. We have 6m plus 5 is equal to 0, or m plus 3 is equal to 0. So we have this ends up being m is equal to a negative 5/6, and this is m is equal to a minus 3. So there's our answers for this problem. So this problem, we're going to try to show you the objective solving using completing the square. So we're looking at problem number 45 on page 146, and we're solving for t. So in this problem, we don't have to put it in quadratic form. Why? Because we want to put the numbers on the right side of the equation, and the variables are always on the left side of the equation when we're completing the square. So the idea here is we're going to take the middle number, the t number here in this case, the coefficient, we're going to take half of that and we're going to square it and add it to both sides of the equation. So when we do that, we get t squared minus 8t. We take half of negative 8, which is negative 4, and we square it, and we get 16. And we're going to add it to both sides of the equation. Now, we have a perfect square on this side of the equation, so we have t minus 4 squared is equal to a minus 8. Now we use the square root principle, and we see that it's t minus 4 is equal to plus or minus the square root of a negative 8. So we have t minus 4 is equal to a plus or minus 2. I can take a 4 out, and I'm left with a negative 2. And now I have t minus 4 is equal to plus or minus 2 square root of a negative 2i. And the book will probably put the I in after the 2. So here we have 2 is equal to, t is equal to 4 plus or minus 2i square root of 2. Oh yes, by the way, we want to make sure that we get this correct. This should be 2 here, because we have the I there. So there's our solution set. Our solution set is 4 plus 2i square root of 2 and 4 minus 2i square root of 2. So our last objective is solving using a quadratic formula. So solve for a quadratic using the quadratic formula. This is number 63 on page 146. So the idea here is if we have the form ax squared plus bx plus c is equal to 0, then solving for x, we have the following formula by completing the square, obviously. Minus b plus or minus the square root of b squared minus 4ac divided by 2a. So we're going to use this information to solve the original problem that we have here. So our problem, I'm going to put it in quadratic form. So it's going to be 5c squared, because I'm going to add 5c squared to both sides of the equation, minus 7c plus 3. This is equal to 0. So now I have a is equal to 5, and b is equal to a minus 7, and c is equal to 3. And so now we have x, we'll put it in the formula, minus a minus 7 plus or minus the square root of a negative 7 squared minus 4 times a, which in this case is 5, times 3, all over 2 times 5. So x is equal to 7 plus or minus the square root of 49 minus 60 all over 10. So x is equal to 7 plus or minus the square root of a negative 11 over 10. And we can rewrite this as x equals 7 plus or minus the square root of 11i all over 10. So that completes our set of slides for the in-class presentation. Please go over some of the video and work some extra problems if you still need practice.